This is the solution video for section 9.3, problem number 4. All right, consider the differential equation dy dx equals 1 half x plus y minus 1. All right, so first of all, sketch the graph. All right, so once again, okay, we're going to take half of the x value plus the y value minus 1. All right, so this one is a little bit more work, so I'm going to write it out. All right, so the first one, half of the x, so half of negative 1 plus 0 minus 1. All right, so half of negative 1 is negative 1 half. Minus 1 is negative 3 halves, so it's negative 1 and a half. All right, here, that's 0, 0. So half of 0 plus 0 minus 1. So that'd be a slope of negative 1. All right, here, half of 1 minus plus 0 minus 1. All right, half of 1 is 1 half. Minus 1 is negative 1 half, so it's a little less steep. All right, next one, half of 2 plus 0 minus 1, right? Half of 2 is 1, minus 1 is 0, so this would be a 0 slope. All right, over here, that's negative 1, 1. So half of negative 1 plus 1 minus 1, right? So that's half of negative 1, so that's negative 1 half. So the same slope as there. All right, next one. Half of 0 plus 1 minus 1, that's a slope of 0. Next one, 1, 1. Half of 1 plus 1 minus 1, right? So that's half of 1, so that's positive 1 half. All right, then over here, half of 2 plus 1 minus 1, right? So half of 2 is 1, so that'd be a slope of positive 1. All right, here, negative 1, 2. Half of negative 1 plus 2 minus 1. So half of negative 1 is negative 1 half, plus 1 is positive 1 half, so it'd have a slope of positive 1 half. All right, 0, 2. Half of 0 plus 2 minus 1, that's a slope of positive 1. All right, here, 1, 2. Half of 1 plus 2 minus 1. All right, half of 1 is 1 half, plus 2 is 5 halves, minus 1 is 3 halves, so it'd be positive 1 and a half. And then half of 2 plus 2 minus 1. All right, so half of 2 is 1, plus 2 is 3, minus 1 is 2, so a slope of 2. All right, so that's our slope field. All right, so now one thing that you want to make sure is that you realize is that this should be relatively correct. So zeros better look horizontal, negatives better look negative, and positives better look positive. I mean, that's kind of the big thing to think about. All right, but now B says find d squared y dx squared in terms of x and y. All right, so d squared y. Remember, d squared y dx squared really means the derivative with respect to x of dy dx, right? So dy dx was given. So what's the derivative of dy dx with respect to x? Well, derivative of 1 half x with respect to x is 1 half. Plus, what's the derivative of y with respect to x? Well, it's actually just dy dx. And then the derivative of minus 1 is 0. So now, 1 half plus dy dx. That is not in terms of x and y, right? So what is dy dx? Well, dy dx is 1 half x plus y minus 1. So you have 1 half plus dy dx, which is 1 half x plus y minus 1. And so you can simplify by taking 1 half minus 1, and you get 1 half x plus y minus 1 half. So that is what's on the answer sheet. All right, so that's part B. All right, part C. Oh, wait, sorry. The rest of part B. This is kind of a weird question. Describe the region in the xy plane in which all solution curves to the differential equation are concave up. What does concave up mean? Remember, concave up means that the second derivative is greater than 0, right? Greater than 0. So what does that mean? Okay, I'm going to do a little bit of work over here on the side because I ran out of room. What does greater than 0 mean? Well, that means that 1 half x plus y minus 1 half is greater than 0, which means that y is greater than negative 1 half x plus 1 half, right? So if I just move that other stuff, what is that? Well, that's actually a linear inequality, isn't it? Y is greater than negative 1 half x plus 1 half. So y equals negative 1 half x plus 1 half is a line with a slope of negative 1 half and a y-intercept of positive 1 half, right? So it looks something like this. But if y is greater than that, then that line would be a dotted line, right? And we would shade everything above that. So what does that mean? That means that if I go back to the question, okay, describe the region, right? So we would say all points above y equals negative 1 half x plus 1 half would have solution curves that are different, that are concave up. All right. All right, but what about C then? All right, said let y equals f of x be the particular solution to this differential equation with the initial condition f of 0 equals 1. Now notice it doesn't say to find that solution. It just says, does f have a relative minimum, relative maximum, or neither at x equals 0? So now, okay, if d squared y dx squared we just figured out, and we know dy dx, this is actually a second derivative test question. So second derivative test. So what did second derivative test say? Second derivative test said the first derivative, so dy dx evaluated at 0, 1, must equal 0. Is that true? Half of 0 plus 1 minus 1. That is 0. So that satisfies the first part of the second derivative test. So now we need to figure out whether the second derivative, d squared y dx squared, is greater than 0, less than 0, or equal to 0. So d squared y dx squared evaluated at 0, 1. All right, so remember that's what we have right up there. So half of 0 plus 1 minus 1 half. So half of 0 is 0 plus 1 half minus 1 half is equal to positive 1 half, which is greater than 0. So if the second derivative is greater than 0, remember, it would look like this, right? Therefore, there's a relative minimum. So relative minimum at x equals 0. Why? Because dy dx equals 0 and d squared y dx squared is greater than 0. All right? All right, and lastly, D. Find the constants m and b for which y equals mx plus b is a solution to the differential equation. All right, so let's think about this. This is the solution to the differential equation, right? Therefore, its derivative, dy dx, is equal to, well, what is the derivative of y equals mx plus b? Remember, it's just m, right? M is a constant, right? If it's a line, y equals mx plus b, then the slope is its derivative. So what does that mean? Well, go back up to the top. M would have to equal 1/2 x plus y minus 1, right? That was the original derivative. But let's go one step further. If dy dx is m, right, and this is a line, then d squared y dx squared is what? Well, what's the derivative of m? Remember, m is a constant, so its derivative would be 0, right? But we also figured out that the second derivative is 1/2 x plus y minus 1/2, right? So what is the only way that 1/2 x plus y minus 1/2 can equal 0? Well, if y is equal to negative 1/2 x plus 1/2, right? So y must equal negative 1/2 x plus 1/2. Therefore, m is negative 1/2 and b is positive 1/2.